Lost the screen, apparently. This is one of these. Press random buttons until both come up. Systems designed by Microsoft, no doubt. One last try. All right, I guess. Perfect. And jiggled it just right. Okay. So where are we? November 20th. Yeah, we're on templates right now, but in terms of the schedule, okay, I guess there's a few things to address. Assignment 3, you should have submitted it. You should have gotten your assignment 2 marks back on Sunday. If there's issues with the marking, please contact the TA that marked it. I know there are TAs that have forgot to sign their name, at least on a few. So if you do not know who marked it, then email me and I will put you in touch with them. And if, of course, you can talk to the TA, and then if you find their explanation reasonable, that's great. Or maybe they'll give you a few marks, or if not, email me and then I will take a look at it. Although this is a busy time of year, I should be able to get to it. For stuff like this, where I have a queue that I put them in and then they stay there until I have time, which is sometimes sometimes into the exam period. But yeah, I do look at them. So the other thing is the tutorials. So I guess you guys, somebody found an exploit by accident or whatever. I don't know. It's fine. So the exploit was you could tutorial 8. I posted it a bit early, and you could drop in tutorial 7 and get full marks, which is kind of funny. And I appreciate it. You know, it's not a bad thing to be trying out stuff like this or accidentally doing it or whatever. I want to say a few things. Primarily, I think it's a good thing. If you find an exploit, it'd be great if you told me. I kind of get it if you forget to tell me. Like, I get it. These are tutorials, are not worth that much. I will tighten up my code now. Presently, tutorial 8, if you drop tutorial 7 into it, will give you a warning about academic integrity. That was sort of, I put it there as a little bit of to scare people a little bit, I guess. But because there is sort of a line that you could cross that is academic integrity violation, right? And nobody did. People tried it, maybe on purpose, that's fine. Maybe by accident, that's also fine. And for the most part, if you find an exploit, that means you're problem solving, and I'm kind of good with that. That's okay. And in general, if you get away with 1% or whatever, that's also fine. There is a line somewhere way down the road where you're making an organized, concerted effort to try and fool the server. That somewhere down the road, that line does get crossed, all right, into academic integrity violations. Nobody is close to that line right now. Okay, so I kind of want to be clear about that. There is a line, right? You can actually get organized and do things to a point where I will have to report you or feel the need to report you, but nobody's even close to that right now. What happened with the tutorial was just whatever. It's funny. Some people found an exploit. That's great. I will tighten up the code a little bit. And as far as tutorials go, I don't really care that much anyway. So yeah, I don't know, just to sort of be clear, if you find exploits, that's great. You're problem solving. That's actually pretty cool. There does become a point though, way down the road, way far, far away, but there is a line that you could cross that could get you into trouble. Just don't get, so play around with stuff like that, but you know, don't make an organized effort to completely defraud the system. That's all. So yeah, questions about that? Okay. That also means I gotta, yeah, I have to change all my tutorial code now, which is kind of a pain, but it's not that bad. For the most part, what I might end up doing is just copying in new copies of tester files and main files and possibly make files. That means you have to have your naming conventions for your class files correct. It also means that if you write little hacks into the test, which I sort of encourage, right? Just make it work. But now you can't do that anymore because I will be replacing it. On a sort of a related topic, assignment 4 has been released. It will be auto-graded because I'm not super confident that we can get all of your assignments graded in a reasonable time frame. We seem to be behind, which is, you know, probably mostly my fault for the scheduling, but also, well, whatever. We'll leave it at that. So yeah, assignment 4 will be auto-graded. There's good things and bad things. You know, the good thing is you know your mark. The bad thing is it's got to run. You don't get any free marks. So the other good thing about it is that I didn't actually change the calendar, but I pushed the due date back 1 week. Right, so I'm going to have it due on the 10th, and then so you have an extra week to do assignment 4. Okay, questions? Yeah. What's that? Sorry. Yeah, it'll be the same. It's not, so the server's not set up yet. Again, because I have to sort of think carefully about how to test it so that nobody, people try not to let people get away with things. There's always going to be exploits, but yeah. So it's not up yet. I hope to have it up this week or at the latest early next week. So assignment 4 auto graded. Assignment 3 is being marked right now, but yeah. Again, so you have the test script, right? I'm essentially going to run those same tests, but I'm going to collect the data into like into Gradescope, basically. So yeah, the feedback you're already looking at it basically in the test control file. I'll talk a little bit about the structure of assignment 4 as well, but again, there's advantages and disadvantages to it, but you have an extra week to get help from the TAs and things like that as well. So, yeah. Other questions? Okay, I'm going to give you, I mean, we are pretty far ahead in the lecture. So one thing I'm going to do, I mean, regardless of how far ahead we are in the lectures, I do want to give an explanation for assignment 4 because I give you a specification and it's not always clear exactly what the problem is you're solving or what your output is supposed to be or things like that. So I do want to remember to give you output. I also want to try to explain assignment 4 a little bit in terms of what is it. Okay, so I'm going to make a very rough UML diagram. We will start with the control object. And the control object has, of course, a view object. And the view does things like presents a menu, takes your input, and then will print a bunch of things. So this is it's supposed to be a podcast network. Okay, of course, it's a toy podcast network, just like most of our things are toys that we build here, but so this control class, there's a test control as well. I think this is called controller, actually. There's a test control as well. I'm not going to include that here. But this sort of top level object of the back end of this thing is called Podify. and its purpose is to store podcasts along with their episodes. So you can have different podcasts, and each podcast can have a number of episodes. So it would look something like this. So I have one Podify here. I have possibly many different podcasts, and they have they might have a host, category, maybe topic would have been a better word there, but category, sure. Title, things like that. These podcasts contain episodes. And you can, so 0 to many episodes, and you can do things like, of course, print all of these things and explore them. You can print the podcast with the episodes, and the episodes have, in addition to storing things like the host name and the title of the episode, they have a thing called, what do they call it? I called it audio, I think. Right, so you can listen to a podcast, which is really just a text string. Right, so it displays a text string if you play a podcast and listen to the audio. There's also a video field. This is a file name, and if you play an episode with video, it loads in some ASCII art and then displays that. Okay, so it's all just fake, but or simulated audio and video. But yeah, so controller view. So the view can display podcast episodes. There's also a podcast player class, which I think is in the view, but I can't remember off the top of my head. So let's put it in the view. This could be wrong. It's a simple class, uses a strategy design pattern, so you can play either just the audio content, or you can play the audio and the video content. Okay, so that's, I think it's in the view. All right, and then, so the whole purpose is, okay, so I can look at podcasts, I can look at their episodes, but then I am implementing a search function. So I can search for episodes using these search objects. Right, so what I'm going to do is the controller will, so you interact with the controller, you say, oh, please search for podcast. It'll ask you, for instance, for category. So I put in a category, the controller goes to Podify, Podify grabs episodes that have that category and return it in, say, an array or whatever it is. I think it's a templated array. So we have this search class hierarchy. So we have, I think, host search and category search. And then it's in a diamond hierarchy, which means we are using multiple inheritance with the same base class. And then we have a host or category search. Okay, so those things, okay. So there's a Podify, there's a function in here called search or something, and it takes one of these search objects and an array of episodes, which is an output parameter. And so I ask for the search, goes in and search through all the podcasts. You grab every episode that matches this search object, and you put them in the array and then return it, and then you can play those episodes. They're in your playlist now. So yeah, so that's sort of the idea. Is there anything I left out? Yeah, so it's basically podcast network, and you search for episodes that meet your criteria and make playlists. Questions? Okay. Okay. What's that? So let's see, one other thing. if we have this class on Friday, is anybody going to show up? I guess is the question. Or do you want this class? So you guys paid for it, or as if you want it. So if you guys are willing to show up, I'm willing to do it. Sure. Okay. Okay. All right. Maybe we'll go to, yeah. All right. I guess, yeah. So that brings us back to I think it would be a cool subject. It might be reviewed, depends on what you guys want to do. I have, so since we're a little bit ahead of the curve, I have some extra topics in mind to teach, maybe some like, I've been watching a lot of presentations by people in the gaming industry and the gaming industry in general does not like all of the things that we teach you, which fair enough to them. They are in some sense true engineers because for them performance does matter, right? So when we write, you make a web app, and if it's 50 milliseconds or 500 milliseconds, it kind of doesn't matter. In the gaming industry, that matters a lot. So we're teaching you a lot of abstractions. I think somebody might have their okay, that's me. There we go. Yeah, so we tell you all these abstraction layers to do, and you say, it's the right way to do it because it makes your code readable and flexible and all these other things, and all of those things are, basically true. These aren't false per se, but it's not a solution to every problem, that's for sure. So yeah, if I run out of things to teach you, we might look at some performance-oriented programming, or at least some of the ideas behind it, and some of the, structures that people in the gaming industry use. In the gaming industry, they are very, very aware of their data and how it interacts with the cache, because that very slow. Anyway, okay, so last class we were talking about templates. And we had gotten to the first example, which was here. And I guess we didn't get that far, or maybe I forgot to save it. I thought we had gotten a little bit further than this, but regardless, we have this problem here. And maybe we only did get this far. One. Okay, so yeah. So we have a max function. It takes an 3 ints and it returns an int. So we forward referenced it here. We've used it in our main function, and we've put the implementation below just to stay sort of organized. And it returns, in this case, 44, which is exactly what it should. Okay, so now that works, and that works great. Now we want to do it for floats. So I could write this, and it will work because the compiler is going to round all of these floats off and turn them into ints. But that's not really what I want. I could get the wrong answer in that case. So I'm going to copy this forward reference, and then I'm going to change them all to floats. Okay, so I want the same max function, but I want it to work on floats. And then I'm going to take this implementation, and I'm going to do the exact same thing. So copy, paste, find, replace my ints with floats. And you'll notice that I don't have to change any of the logic in here. So all I did is find, replace every int with a float. And this still works because this greater than operator still works. So now when I run it, I get my max int is 44 and my max float is 44.5. That's exactly what I want. So great. I have two functions. I have a function that's overloaded for very similar things. I could compare characters as well, and then I can make a third function. But maybe there's a better way to do it. copy, paste, find, replace is good and probably pretty much error-free, but I am still a person and I can make an error. So what I'm going to do instead is I'm going to make a function template. And then after I make a function template, I'm going to ask the compiler to do all the stuff that I just did for me. So I'm going to say class T. And so this tells the compiler that this function declaration is now a template. And what that means is it's not a real function, does not compile, at least not by itself. And then I'm going to change these to this type T. So this T is, I'm telling the compiler that there is a type that could be used with this, but I don't know what it is. This is just a placeholder for it, but it is a class. Okay. It's not necessarily a class, but I can use the keyword class here. And then what I'm going to do is I'm going to go down here and say, well, since all my max functions seem to use the same logic, I'm going to say, here I'm going to be different. I'm going to put type name, because, you know, why not? I'm going to replace all of the ints with t's, and now this is the implementation template for my function. Okay, so what does that mean? The template means that, again, this is not a real function. It's not a real function until the compiler makes it into a function. Okay. So I used class up here. I used type name down here. That might be a little bit confusing, but in this instance, these two keywords do the exact same thing. Okay, no difference in this context. At least I have dug and not found any differences. There are differences in other contexts, but in declaring templates, you can use type name, right? Or you can use class, and they will do the same thing. Okay, so I like to use class because it's shorter. I also like to be consistent. If I use type name there, it's probably I'm trying to communicate something. Okay, so now what happens is the compiler goes, it sees this max function. Before it found the declaration up here. Now there's no longer a declaration for ints, but there is a template. And if I put ints in for all of the t's, then it would match that declaration, right? It would match that signature. So then the compiler says, okay, well, since I cannot find a max function that looks like this, I'm going to make one. It goes down, it starts here. It does a copy paste, find replace, replaces the t's with ints. And now I have a forward declaration, a forward reference. And then it comes down here, it does a copy paste, and then it does a find replace the t's with ints again. And then it compiles everything. And if this compiles when we put ints in for the t, then we have a function, right? Then it's a real function that we can call on. And then it comes down to this line. It says, I need something for floats. I don't see a function with this signature, but there's a template that has a signature that I could use. So again, it does a copy, paste, find, replace t with float, and the same thing down here. So I call it with two different types, and the compiler gives me two different functions. And these are different functions, and they're both compiled with my code, and then hopefully they both work. Okay, and I get the same output as before, but now instead of doing all that work myself, I just made the compiler do it. Okay. Questions so far? Yeah. That would be a better way to do it. Yes. And we're gonna get to there. Sorry, when we start looking at standard template library and algorithms, we're gonna look at passing functions, and then we'll look at passing functions in detail probably. Yeah. That would be better. But what we're going to do is we're going to say, well, yeah, this doesn't work with any type. This works with any type that will compile if I replace T with that type. So I can still, this is not, you're right, it's not as useful as it could be. But I can still use it for any type that uses this comparison operator and this assignment operator, which is, I mean, everybody gets the assignment operator. Well, this is technically calling the constructor. Almost everybody gets an assignment operator. Sometimes it's deleted. Okay, so let's say I want to use it on my type. In particular, I have some time objects. We did see these. They are just simple, very, very simple objects, hours, minutes, and seconds. And they print out, and I can print them to an output stream. So yeah. So now I'm calling this max function again, and I'm putting in these 3 time objects, and you can see the compiler's not complaining yet because it's just a template. When I try to compile it, I get an error saying that I don't know how to compare 2 time objects using this greater than operator. Okay, so this is how the compiler discriminates between something that I can use here, a value that I can use, and a value that I cannot. And yeah, and if we allowed a custom comparator to be passed in, then we could basically do whatever we like. But in this case, we still have an option. We can say bool operator greater than. We can implement this operator and then time. And we can return convert to seconds greater than t dot convert to seconds, just to make our life easier. Almost. Okay. So now with that, we've overloaded that operator. Now if we substitute time in for t, that should compile. So let's see. Compiles, and it runs. The maximum time is 1654, which, yeah, that looks to be true. Okay, questions? Yeah, so copy, paste, find, replace, that's all templates are, but the compiler does it for us and then compiles new functions as needed, but only as needed. If we don't call max at all, then no functions will get compiled. Okay. So yeah, this is just a review of all the things we talked about. If we had this function and we wanted to do something logically the same for floats, we could just make a template. So we declare the template with a type t, and I guess, yeah, we'll come back. There's other details we could talk about. We will come back to them. So what happens then is we call the function with any data type, and if that, it's a, this is known as a parameterized type. And if now the function signature, if I substituted those types in for the type marker, if it compiles, then I get a function. Creates a separate function for each of the type used, and again, just the copy, paste, find, replace, exactly as if we overloaded that function ourselves. So in addition, the compiler is pretty smart. We can overload existing functions with templated functions, and the compiler will simply look for the existing function first. For instance, if I did something like this, and I said, maybe somebody else made this max function, and I can't really get rid of it because it's simply compiled along with my code. But but I don't mind using it because it works and behaves the way that I want. I just want some extra functionality from my template. Well, that's fine. And we can write in here. Okay, so now when the compiler goes through, it's going to check to see if there's a function that matches the signature, and it's going to find two potential candidates, right? One here and one here. But if this already exists, it's not going to bother making a new one. So it's just going to use the existing one. And then we get, yeah, so in my call to max int, we get the non-templated version. And in addition to that, we can do things like this. If v1 greater than okay, so my keyboard is not quite as responsive. It's Bluetooth. All right, so I can overload this function with other, same function name, slightly different function signature. The point is that the compiler will be fine with that. Right, I can do a max int between two. I have the same function name, but a different number of parameters, which gives me, it's technically overloaded, but only with by parameter type. Okay, questions? All right, so that is function templates. So there's also class templates, and basically what we want with a class template, well, maybe there's a function we want to overload the same way we did with, or we want to make a template out of it, the same way we did with our global function. Well, if we do that, we have to make the entire class a template. We can't just make part of it a template. So what we're going to do is we're going to create a class that works with any data type, where let's put any in quotes, because it really depends on what function calls I make with it and what, so what properties I need in that data type. So again, I'm going to declare my class with a type parameter, T for instance, and then I can use this type T anywhere I like in the class. I can use it as a data member. I can use it as a local variable or parameter in a function call. And so you will see this used a lot of the times with collection classes, right? So collection classes are types of classes where we can write, we have basically the same general things we want to do: add, remove, insert, sort. And so basically we could do that with just about any data type. So yeah. Okay. So we have a book class, we have our entity book class. So it doesn't do anything special, but we do print them out. Then we have this list class. So we're going to turn this list class into a templated class. So I ask you to do the same thing with an array class that has a backing array. This is sort of the more complicated one, right? This is a linked list. This is my public interface. We have this subscript operator, which, so I'm going to grab something at an index. The subscript operator may be a little deceiving because that usually kind of implies random access, which we definitely don't have. We have add, remove. Yeah, so this is a linked list class and everything's implemented as a linked list. So this is sort of complicated, but I'm going to show you how easy it is to turn this into a templated class. It's not difficult at all. We're just going to turn everything, every book pointer into a type T. But before we do that, let's do a proof that this all works. So we're going to make 4 books. We're going to add them to our list of books currently that only add book pointers, and then we're just going to print them out, not even using the list cout, but sorry, P3. Okay, so there's our list of books all printed out. So now we want to template this list class, and we want to do it so that we basically get the same functionality. Okay, so I have my list class, and I'm going to say template class type T. Okay, so a bunch of things go red. That's great. We have all the implementation in the same file. I'll explain a little bit about that after, but for your array class, I recommend you do the same thing. It makes things simpler. And again, I'll explain why a little bit later. So what we want to do, well, before we start, this is a bit of a complex lesson here, which we will save till the end. So we're going to ignore this output stream insertion, insertion operator. We'll just work on the list class itself. So now everywhere we see book pointer, we want to put T, not T pointer, right? If I put T pointer, then I'm sort of enforcing something. If somebody wants, sorry, if you, pardon me. All right, so if I implemented it as a pointer, then now I'm enforcing something, right? So now if they store T, they can't, if I store a vector, I can store a vector of book pointers or a vector of book objects. And the same thing with an array. But now I'm sort of forcing people to store pointers. So I don't really want to do that. I want to give them the choice. So I'm just going to make, all book pointers are going to turn into T, and then they can store book pointer if they want, book object, int, whatever they want. Okay, so I'm going to turn all those to T. And then this also will be T. Okay, so now my function declaration, or sorry, my class declaration is looking good. This is sort of what I want. There is an argument to be made to pass these T's by reference. It's a pretty good argument. We're going to keep it simple for now. We're going to pass by value. Okay. I really have a frog in my throat for some reason. I apologize. So the compiler doesn't like this declaration now, or implementation. And so now, in fact, I have to change all of my implementations into template implementations, right? So these are, I'm telling the compiler, this is not actually a function. This is a template of a function that belongs to this templated list class. The other thing is, there is no list class anymore. There is only list T. There's only list with some template argument. Right, so everywhere that we see list, except for right here, has to be with this parameter T. Okay, so we can see the compiler's happy now. Our constructor is working fine. I don't see any book pointers in here, so I don't have to change any of that. Do I delete the data? I don't think I delete the data. Okay. This also is a template. Oops. And again, there's no more list class, so this is a list T class. And I am going to look for any reference to book pointer, and there's none, so this looks fine. Logically, it's okay. And then I'm going to do that same thing for all of these implementations. So yes, bear with me. Is empty, that's fine. There's no book pointer. Here there's a book pointer, so I do have to take care to change that to T. Inside here, I missed one last time, but That looks all fine now. I have a book pointer here. In fact, I'm going to change this into TT. And then this should be T. Nope. And everything else looks good. E. Yeah, okay, so I have a book pointer here. I want to change that T equals current node dot data, and then return that T. So I had to make a few changes, but it's just really changing that all of the things that we stored before. In this case, it was book pointer. We're just changing those out for T. And now all of my red has gone away. The compiler is once again happy. I have a templated list class that should work basically the same as my original class. Of course, now I have to give it a type declaration. So I want to store book pointers again. And if I store book pointers, all of this functionality stays the same. And voila, I have the exact same implementation, but now I have a templated list type. Okay, so easy peasy. There are a couple of caveats which we're going to get to, but any questions so far? Okay. We can also do other things now. If I, call a list, and I can make it a list of ints. I'm going to call it array ints because that's what I called it, just to make my life easier. And then I can add a bunch of ints, and then I can print them out. Oh, it's not going to like this. I will have to print them out individually. We'll come back to this after. Okay, so I made a separate list that stores ints. I added 5 ints, and then I printed them all out. And yeah, that's my list of ints. The number is 0 through 4. Now, what happened is, again, this entire list class is now a template. So the compiler reads it and says, okay, I have a template. Then it comes here and says, oh, somebody declared a list of book pointers. So it goes, takes this template, copies it, pastes it, does a find replace on all T, and replaces it with book pointers, and then compiles it. And as we saw, that works because that's what it was originally. So then the compiler creates this new list class, list book pointer class, and then we're all happy. But then it gets down here and says, oh, I also need a list of ints. So it does the same thing. It goes into the template, copies, pastes, does a find replace the T with int, compiles it, and that works. So now we have this class list of ints. So when we ran this code, we made 2 classes out of our 1 template. All right. So the other thing is this output stream operator. What if we want to overload that for a templated class? Okay, well, let's do that. I want to declare, so I'm going to declare it a friend of my class so I can use the private member variables. There is a problem, as I mentioned. So the compiler does recognize this. If I try to compile it, will it be okay with that? So it's giving me a warning. This is a non-templated function I'm declaring. Yeah. Okay, so it gives me some warning. So yeah, what it's telling me is that I should have made this into a templated function. I could do this, but the compiler is not going to be happy with that either, right? So I'm declaring T here, but technically this is not part of my list class. This is a global function that is a friend of my list class. So it's not necessarily going to be of type T. It's going to be of whatever type I pass it, right? So it's, or more specifically, it's not necessarily going to be of type list T. It's going to be of whatever type I pass it. Because it might be that this function does not get compiled for this class. So what I need is well, first of all, this is basically a forward reference to this function, and it's a templated function, so I'm going to have to declare that it's a template. If I did this, okay, but now this T is hiding this T, which is going to cause problems. And again, the compiler will probably warn you about that. And in fact, it's going to give you an error in this case. So when I forward reference a function as a friend inside my class, I have to use a different type, even though, technically this is my list class. So I have to use I have to declare it a template, and then I have to use a different type from the type being declared in my class. All right, questions about that? Yeah. All right, so now in our implementation, again, this is now a template of a function, and you can see that the compiler does not know what we're talking about. So let's tell it, well, this is actually a template with a class T, and this is a list with type T. And now everything seems to work. Okay. So we have an output stream operator. So instead of doing this, let's just send list books. And instead of doing this, we will do list array of ints to the output stream. Okay. Compiler's not complaining, which is a good sign so far. So the compiler did run into a problem here. And the problem is it's kind of a weird one. So I'm going to explain it. You don't encounter it that often, or at least I haven't. Maybe you will. So what's actually happening here is that because this is, first of all, let's try that way. Okay, current node was not declared in the scope. Yeah, parsed as a non-type. Okay, so what it's saying is that this is actually ambiguous, right? Because it doesn't know if node is actually a variable that I'm multiplying times current node, or if this is a type declaration of node pointer. Which I don't quite know why how that ambiguity can arise specifically. That is, I don't have an example where I have two things that mean two of the same lines that mean different things. I'm assuming they exist. But in any case, here we have to help out the compiler. So we're going to tell it this node is a type name. This is not a variable that I'm multiplying times current node. This is actually a type. So that's where one place where class and type name differ. Again, C++, of course, there's a million tiny little details. But if you ever run into this problem, that would be how you solve it. So now, finally, we have a print function. And look at that. My books are now a list of pointers. My ints print out great. The books, not so much. That's the problem with overloading these output stream operators and making them a template for a collection class is I don't necessarily know what the person is storing. So I don't necessarily know how they want it printed. So mileage may vary. Typically what you would do is you could make a non-templated operator overload and then specifically print it out a certain way. Actually, let's try that. Let's make this into book pointer. I'm not sure if this will work or not, actually, but it will be interesting to try. But this is sort of what you would do with, yeah, it's not going to like that. Okay, so this is sort of what you would do, but what you would do is implement this where you've declared this class. Okay, anyway, we'll see this when we get to, oops. We'll see this when we get to vectors. So typically what you do, the stream insertion operator is not overloaded for vectors. What you have to do is overload it, but for concrete implementation, right? So I can overload it for a vector int, for instance, but not for general vector class. It's not implemented. Okay, questions? Okay. Okay, so this issue of why do we keep our header declaration and our implementation together in this list class, because this is what I recommend you do. Well, the problem comes if I try to compile it into an object file. So let's say I separate it into list.h and list.cc. And so I have in my list.cc a bunch of implementations, but they're template implementations, right? They're on list T. And then I try to compile an object file. Well, what type is T? The compiler has no idea, right? So that won't compile. There's ways around it. I can, if I know, for instance, that I wanted a book class, I can, at the top of my list.cc, I can forward reference list, a class, list book pointer, and then it will, well, I couldn't get it working last time, so there were some bugs. So you would do something like this. I tried to do it for the other class, it didn't quite work. But there is a way to do it. So you're gonna, basically, if you tell the compiler what types of classes you want in your object file with an exact type instead of T, then it can do it for you. And then you can link it. Of course, the easier way is, and what I would recommend is just keep everything in the same .h file, and you will import the entire thing, but that's okay for templated classes. All right, questions? Okay. All right, and the other thing to remember, if you overload the stream insertion operator or extraction or anything really as a templated function, you have to declare a different type here. So V instead of T, it's just a syntax thing. This is, yeah, this is the problem. We've already talked about all this, the difference between class and type name. There's no difference between these two statements, but type name does have a use in some cases. Okay, and yeah, what the compiler does, so what we do, we declare the class with the type variable. It's a templated class, and then every implementation is templated. And then the compiler, when I make a new class and I give it a concrete type, it creates a new class for each data type used, right? So copies, pastes it, find, replace, compiles it, and if it compiles, then you're golden. Okay. So we're going to look at templating a bit more. We're going to look at a couple special cases, multiple types, non-parameter types, and default types. I was considering wedging multiple types. I was considering putting these in assignment 4, but I didn't. I don't know. Didn't have time to implement it correctly. But yeah, we'll look at them anyway. Okay, so here we have a map item, right? So in a map item, or in a map in general, is basically a collection of key value pairs. So in this case, our map item has a key of an integer and a value of a string, and we can store things in this map item. And then, if we wanted to retrieve the string that was associated with a certain value, we could do that, right? It's basically a dictionary, or it's a dictionary. So in our main function, we make an array of map items. This is a statically allocated array of map item objects. So then we can simply call set on each of them. And then, we can associate each of these hockey players, which are probably even before my time, some of them, with their number, and then print them out. And we will make sure that works. And then we'll change my map into a templated type. P4. And when we print them out, we get the key value pairs. Okay, so great. So now let's make it into a template. Again, I'm going to use this template, but now I want a key value pair. So I'm going to declare, class K and a class V. All right, so now I have two templated types, which is going to make a mess of a bunch of stuff. This friend operator, this friend function, it's going to be a templated function as well. But again, I can't use K or V. I have to use A or B, so I do not get an error. And then this is a type map item AB. Okay, so now everywhere I see int, I'm going to put in K for my key, and everywhere I see string, I'm going to put in V for my value. And I have this one set operation that I want to implement. K, V, and this must be K comma V. And then that works fine. My output stream operator, K comma V. And that's going to work as it is. So I can have a templated class on two types. And basically the syntax is all very similar, but now when I declare it, of course, I have to be specific and say that I want an int and a string, but everything else should work the same. Okay, so I have all these key value pairs, prints out the same. So that's two different types, which is, maybe not super impressive, but in addition to that, we can have nested types. So here is my map item again, with sort of the same implementation. And then I have a my map, and that honest to God, I cannot tell these words apart for some reason. But regardless, I'll do my best. So now I'm going to have a collection of map items in my, so I want a pointer. Basically, this is a wrapper for my collection class of map items. So I want a pointer, and that pointer is going to point to a backing array of map items inside my map class. And what I want to do here is these are nested templated types now. But in this case, I am going to use the T and V that was declared with my map, because I want to make sure that this map item uses the same types. Right, and then I call it, what did I call it? Array or something? I don't remember. Yes, array. Okay. And then for some reason, I didn't write these functions, so let's do that. T and V. Good grief. What is it? A my map. T comma V. my map constructor, and then size equals 0. And I'm going to initialize this into new map item TB. And we'll give it a size of 4. Okay, so that's just, we're just going to hard code that for now, and then we'll see some alternatives to that later. In this dumb add function, let's do that. But I'm going cross-eyed with the maps and the T's and the V's. Void add. Okay, and then okay, so if size is greater than or equal to 4, I'm just going to say map full. And then exit. Now this is not super graceful, just to sort of bail on this. But what it is great for debugging, right? So when little things like this go wrong, it's really nice when your program crashes, because then you can try and figure out what caused my size to be, what caused me to try to add something to something I shouldn't have. But if this works, then I will say array at size plus dot set T and V. Does that look right? The compiler happy, the compiler's happy. Perfect. Okay. So I've implemented this my map. It's basically a wrapper for an array of map items. I didn't implement the destructor, but we'll all live knowing there's a memory leak there. So yeah, this should, so now I make a my map, I declare it of type int and string, and then I call add, and then I'm going to print it out, and it should actually do the same things it was doing before. Yeah, except for the fact that for some reason, at some point, I decided I might want to call it a KV pair instead. All right. Okay, so again, I get the same implementation, but now I have nested, these nested templated classes. Okay, questions? All right, nothing groundbreaking. We'll do one more quick example, and then we'll lay this to rest. Actually, 2 more quick examples. So here I made a my map of size 4, but maybe we wanted to, for instance, add somebody else to our hockey team. Right, so now we have 5 people. And when I print it, it says map full and it bails. Okay, so I want to make a my map, but I want it bigger. So what I'm going to do is I'm going to put a third thing here, a capacity, and it's going to be an int. Right, so really this is just a parameter list, this template thing. So here the T is of a type class. It's a type, it's not necessarily a class, but class sort of covers everything we want covered. V is of type class, C is of type int. So it can take an integer value. Now I need to, yeah, that should be okay. Now I need to add this third parameter everywhere where I've declared these templates. And add it to the declarations. And what that's going to allow me to do is in my constructor, instead of making it a size 4, I'm going to make it a size C. Right, so now I'm going to pass this in as a parameter that's going to tell me the capacity of my map. And here, instead of checking to see if it's greater than or equal to 4, I'm going to see if it's greater than or equal to C. All right, so I'm passing basically a constant into my class and then using it in my functions. Now in main, yeah, the compiler's not happy, but I can say, well, I actually want a my map with 5 spots so that I can add 5 people to my hockey team and then print them out. And lo and behold, there we go. And if we tried to add a 6th, then it would bail. Okay, so we're allowed to add parameters. The catch, well, there's a small catch. The catch is that when I declare, for instance, should really set this up better. But let's say I made map 2, and I use the same types, then this is actually the same class, right? So when the compiler went up here, it made a my map class with these parameters. And then when it came down here, it said, oh, I already have one of these. So map 2 is going to be the same type, which is great. So these are the same class. If I did this, suddenly these are different classes. Very, very similar, right? The keys and the values are the same, but the capacity is different. And because I passed that as a type, these are 2 different classes. Now, in this case, we probably don't care, right? This is not going to make a big difference. But if I had static variables in my map class, right? If I had class variables and I changed them for map, this would have its own class variable. And maybe that's not the behavior I want. Maybe it is, but yeah. Yeah. All right, that's fine. Questions? Okay. The final thing is maybe, yeah, 5 is great. Maybe I want 5 to be default. Maybe I don't want to put 5 every time. I just want to put a number if it's going to be something different. What I can do is I can say, well, this should be 5, right? I'm going to give it a default value, and then nothing else has to change in my declaration. And nothing else has to change here, but if I wanted to, I can leave this off. Okay, so now print it out, and I still get my 5 hockey players being printed out. So this still works. So yeah, there are a couple of caveats to that. I mean, in addition, I can say, well, I want my int c to be 5, and I want my this by default, let's make it a string. My value is most of the time it's going to be a string, so let's do that. And in fact, my key most of the time is an int. So I'm gonna pass in all these default parameters, right? And then what I can do is I can declare my map with an empty pair of these things. And it still works exactly as it did before. Okay, so really this templated type is just a parameter list. That's all it is, except we're saying this is a class T and this is the name of the variable. In some sense, it's exactly the same. And the same as when I use a parameter list and I give the parameter list default values, a function, let's say. I do this. So now I have T has a default parameter and C has a default parameter, but V in the middle here does not. Well, when I tried to compile that, the compiler does not like that, right? So the parameter list for these templates follow the same rules in terms of default values as the parameter lists and functions. That is, they have to be all to the right. Any that are not default values have to be to the far left. Questions? That's it for basically templates, or at least this example. We still have a couple more things to cover: vector and smart pointers, and we got 10 minutes. Okay, so yeah, template types really are parameters. I can pass in any type, right? I can int, float, whatever I want, strings, or classes. But every time I give different values to those types, the compiler is going to make a new class. So that can be awfully inefficient. If I'm simply passing a simple capacity value, there's probably better ways to do it. But, you know, sometimes in C++, maybe you want to do that. And we can assign them default values and then instantiate a type with empty angle brackets and save ourselves some work. Yeah, so in Java, you can do things with generics such as, let's say I had a list and I want the list to only store numbers. Now, what is it? Sorry. How does it go? Extends. I think it's something like this. Regardless, you can do something like this in Java, right? Where I can say, I want a list of generics, but T has to be a subclass of number. So I can do ints or floats or big ints or things like that, but nothing else. I can't do strings or whatever else Java has. You can't do this in C++. There's no functional way to, well, there is functional ways to do it. There's no way syntactically to do it like this. I can sort of only implicitly control the types that are going to be made. And I have to kind of be clever about it. So in my class, I could say, well, my list class, for instance, I can make a function and I can say, well, I'm going to make a pointer and I'm going to make a new type T. And the compiler is going to be okay with that as long as T is a base class or a child of base class. The problem with that is, even in my class, if I don't call this function, it does not get compiled. So it would only work if I made a call to it. So let's see if I can. My map, let's make a dummy. And maybe I only want to be able to store strings as my values. So what I'm going to say is b equals, wait. Yeah. Okay. So then let's try and compile that. Am I in the right place? Yeah. Okay, that works because v is a string. Let's change that to, what do I want? Let's make that an int. So say int x. So I want to try and break it, right? So the value currently is all stored as a string. And I'm going to say, well, then I have to be able to compile this so that I can make, and lo and behold, even though I made v into a string, it still compiles because I didn't ever call this dummy function, which this is like a trap waiting to be sprung, because it's not just this. I mean, my dummy function in this case, I'm trying to restrict the types that I can compile my code with. So my code is working fine. I'm happy. Everything's good. Down here, I say map2.dummy. Right. All of a sudden, my code doesn't compile anymore because I tried to call the function. Right. So this is one of the dangers of templates. is that if you don't call a function, even in your class, it doesn't get compiled. And if it doesn't get compiled and then you add it to your code later on, suddenly code that works can break. Right? So this is one of the major drawbacks. You know, I guess that's a design decision for efficiency or whatever. And you can do things like this. So I can call this in my constructor to make sure I can restrict my values now to be type int. But yeah, this really is a landmine. You know, it's a trap waiting to be sprung, basically. So yeah, questions? So yeah, be careful of that if you're using templates, making templates. Okay, so that brings us to the standard template library, and so we're going to look at vectors specifically, but the standard template library is basically, we've been trying to avoid it so far so that we can do everything and learn from, you know, basically basic principles, which does help in the long run, right? So if you just learn libraries, if you just learn platforms, you miss certain things and you won't be able to, for instance, debug the library or debug the platform. And that does happen, right? There are bugs in these things. They are really frustrating when you find them because you realize all along that it wasn't your fault. But yeah, they do exist. So if you learn from first principles, then that will help you debug these things. But so we've been staying away from it, but it is actually quite useful if depending on who you talk to. Vectors are at least very useful. But it provides many container classes and algorithms. So arrays in general, they're fast, they're primitive, which gives them certain advantages, but there are a lot of trouble. No bounds checking, doesn't support operators. I try to write a piece of C++ code for research purposes. And to do that, I tried to implement, what did I do? Well, I did a couple of things, I guess. So you can declare two-dimensional arrays in C++, but I kept running off the end of my arrays. I thought, well, I'll just be very, very careful and not, you know, call on a location that doesn't exist. Of course, that didn't happen. So yeah, I had to write a wrapper class for my two-dimensional array because I just couldn't do it. I don't know, man. I'm not that careful for some reason. I'm prone to dumb mistakes, and so me with arrays just doesn't fit. But yeah, we're going to look at the vector class template, I guess, on Wednesday. So it is a templated class, right? When we declare it, we have to give it a type. Stores any data type, supports many operators, and has a useful function. So supports many operators. Like I can compare two vectors to see if they're equal or not equal or things like that. Not going to start this example today, though. I think if there's anything I want to add to that. So next class, we will talk about vectors. We've already looked at them a few times, but we're going to look at them in more detail and see, you know, sort of what happens behind the scenes. And maybe we'll run a little comparison vectors to linked lists, or maybe I'll wait till algorithms. And you'll see how much faster a vector is than a linked list in general. Not in every case, but in general. And then we'll look at smart pointers and make them generic. That shouldn't take very long. But yeah, that'll be it for today. I'll see you guys on Wednesday.